That's terrifying.
Hello, I'm Tom Coughlin, and I'm moderating this session, CXL, Expanding the Memory Ecosystem. So you've heard a lot about CXL during the Persistent Memory and Computational Storage Summit here. So what we're going to do is we're open to questions you folks may have. We got a few questions to seed things as well, but you can ask questions via the Q&A button on the bottom of the Zoom window, and you can see other attendees' questions. And you can upvote them, so you can actually get a question pushed to the top if you really like it. I think you can only vote once each, though. So you vote for your favorites to be answered during the session. We'll try to get to as many questions as possible, and we'll connect with the panelists. And we've got a number of great panelists also via the Slack channels during the event. So I've got my Slack channel open so I can see stuff, and we also have the Q&A. And also there'll be just to let you know that there's a post-summit evaluation summary, and I see it's already come into my email, and it's probably come to yours as well. So be sure to fill that out. So this session is going to talk about CXL. It's an open industry standard, provides high bandwidth, low latency interconnection. It works with multiple types of memory, and we'll discuss how CXL works, how it changes the use of memory, accelerators, and memory management, as well as use cases, availability of CXL, and how to get involved in the CXL and standards and implementation activities. So here's our panelists. We have Stevie Bates, Chief Technology Officer for Eideticom, Chris Peterson, Hardware Systems Technologist at Facebook, Glenn Ward, Senior Director, Azure Technology Development at Microsoft, Leah Schoeb, who is a Senior Developer Relations Manager at AMD, David Wang, Director of Memory Product Planning at Samsung Semiconductor, and Hao Zhong, who is CEO at ScaleFlux. And one more thing, just a bit about compute memory and storage consortium group that we've got within within SNEA here. It's wrong organization. So CSMI, we have engaging in education, including the event we're doing here. We work on standards, and we also propel technology adoption. You can find out more on the link at snea.org/CMSI. So all kinds of resources, fun stuff to do, and CMSI put on the event that you've been attending the last couple of days. And with that, Chris, if you're here, I will do the slides. You just tell me when to go to the next slide.
Thank you, Tom. I am here.
Okay.
All right. We thought we'd start off with just a little bit of background. So I'm going to talk a little bit about what actually is CXL. So first of all, CXL stands for Compute Express Link. It is an open industry standard designed interface by the CXL consortium. And the interface is fundamentally a cache coherent interface that allows us to interconnect processors, memory expanders, accelerators, and other types of devices. So the goal of the interface is to provide both high bandwidth and a low latency memory access solution. It's built on top of PCI Express and allows us to mix and match the right protocol for the right endpoint solution. And it adds additional protocol options with what we call CXL.cache and CXL.mem, which allows the CPU to share its local memory with a CXL device and vice versa, depending on the type of architecture that you're pursuing. It's also implemented as an asymmetric coherency solution, which means the burden of managing the coherence across all these devices still remains within the CPUs. And that allows us to design simpler endpoint devices at the end of the day. The organization is, as I mentioned, an open industry standard organization. So next slide, please, Tom. It was founded in 2019 by a group of promoting companies. And since then, we've expanded the board of directors to the companies you see here. And we're very well represented by some of the major players in this industry. including all of the CPU architectures. Today, we've grown to 130 member companies and continue to grow. And there's a nice rate of design and development that we're going through. Last fall, we released the CXL 2.0 spec, and the organization is currently working on the 3.0 spec. Next slide, please. So as we get into talking about memory specifically, let's look at the different potential device types that could be built with CXL. So today we have 3 different device types defined. The first one is a type 1 device. This is basically a CXL device that has no local memory and leverages the memory attached to the processor and can cache that memory for specific operations. So typically this could be different types of network interface cards, for example. The second type is a type 2. This is what we often think of when we think of accelerators. So whether for dense computation or GPUs or other applications, this type of device has local memory, but also needs access to host memory. So it can partition and cache local copies of that memory on the accelerator itself, and also access the host memory as it makes sense. Finally, the type 3 device is what we're really going to focus on today. And primarily, this is memory buffers or memory expanders. So this allows us to build a CXL device that has some type of memory behind this device, and then share and expose that to the host processor, and map that into the aggregate address space. The interesting aspect here is that this can be designed such that it is memory agnostic. So you could put storage class memory or various types of media behind these types of memory expanders. Next slide, please. So I think most of us are in this forum are probably quite familiar with the concept of a memory and storage hierarchy. And I think we're also fairly aware of some of the gaps that exist within this hierarchy. So traditionally, there's been a fairly large gap in terms of both capacity and performance and the ratios there between DRAM and NAND flash. And this is a gap that we believe CXL is very well positioned to help us address in a variety of different ways and with a variety of different architectures. But as a way of abstracting the potential solution space here. But we believe we can fill this. Next slide. All right, so I will leave you guys with that as a general overview for CXL before we get into Q&A. And just ask if you would like to learn more, please do follow the organization on Twitter or LinkedIn, or even better, come join the consortium and contribute your wonderful ideas to the consortium and make it better. Thank you.
Thank you, Chris. Appreciate that. So now we're going to go to the to our panel discussion here, and let me just look and see if we've got any questions. I don't think we do yet. Nope. So we'll get started with some of the questions we got here. So can you folks tell me how will CXL fill the performance gap between flash memory and volatile memory? I know you showed that in your slide there, Chris, but Glenn, would you like to talk to that one first?
You know, I'll probably let one of my colleagues take that. I have a few speaking points for Microsoft that I'll talk to you later on.
Got it. Okay. Okay. David, would you like to talk about that? This is the performance gap between flash and volatile memory.
Well, I think the CXL, provides a relatively low latency way to connect different types of media, right? That's the immediate benefit it offers, right? Without CXL, then you have to basically use the PCIe stack. Mm-hmm. By the time you go through the whole stack and move the packets back and forth, you're adding, microseconds levels of latency. Mm-hmm. So with that overhead, basically, memory types such as DRAM and even storage class memory with the low hundreds of nanoseconds of latency, they basically lose all their value proposition. And it becomes very difficult to kind of justify the cost benefit ratio when you attach those type of media to the PCIe interface. So CXL sort of enables you to effectively, it provides this new generic interface to allow you to kind of explore and put different types of media, as Chris mentioned, not just the DDR, but also the low latency storage class memories is now possible. So that's how it really closes the gap and provides an interface for these type of memories to live. And it doesn't really disturb the DDR interface in that way. So it's an exciting interface for the industry to explore for this new class of memory.
Well, thank you very much. Leah, do you have some more perspective on that from folks that are making hardware? Will actually use this stuff.
Well, one thing that I found, you know, in some recent work that we're doing in acceleration and graphics is direct communication. So with new types of applications and new types of methods to be able to communicate and get direct access to storage and memory, finding that too many trips to host memory just to accommodate all of those different paths. If we can allow for direct communication and cut down the amount of trips to host memory just to have direct communication between, you know, storage and the GPU on a graphics card, you know, those types of things will allow us to be able to accelerate performance. And so areas like gaming and content production, those types of things, this is a huge acceleration for them to be able to have more direct communication. So this is a big breakthrough for us. This is great.
Do you think there'll be GPUs on the on CXL as well then?
There will be if I have anything to say about it.
Okay.
You work for a company that makes GPUs, Leah.
Yes. So Stephen, I'm just going to call on you next. Why don't you go ahead if you have some more input on it.
I think this is a very good question, and there's a couple of things to notice. One of the things that CXL from a form factor point of view allows us to do things we simply cannot do in a DIMM form factor. So, you know, for example, Optane DIMMs or NV DIMMs, they only have a certain amount of space, and more importantly, they only have a certain amount of power to work with, right? So managing complex, somewhat nasty materials that are maybe, you know, non-volatile, but not necessarily perfect in other ways around error correction and so forth. Doing that with a controller that has to fit on a DIMM, that's challenging, right? And so I think CXL allows us to move away from that DIMM form factor to more storage-centric form factors, or even add-in cards, where instead of only having, you know, 10 or 20 watts to play with, we can now have, you know, 100 or even 200 watts to play with. So I think that's a very, very interesting thing. It will allow us to build more complicated controllers that we need for some of these memory types. I think another point is that coherency thing. So, you know, PCIe and CXL have the same electrical specs, but they're very different in terms of how they interact with the cache hierarchy of the main processor. And I think bridging that gap between DRAM, main memory, and storage requires a protocol that's not just fast and low latency, but also allows for the cache coherent hardware in these processors to accelerate things that with PCIe, we actually have to do with software. So if I want coherency over PCIe, I have to do DMAs, I have to check that DMAs have completed, I have to free memory, and that adds such ridiculous amounts of time that it's not even worth trying for a memory semantic type of thing. So CXL gives us that.
Oh, thank you, Stevie. How? Wow. Ho. I keep murdering your name.
Okay.
Yeah. Do you have any more to add on that with regard to performance gap between flash and volatile memory and what role CXL plays?
Sure. I think to answer that question, we need to be very clear about what CXL can help, what it cannot help, right? So it improves the efficiency, latency about interconnection between the CPU accelerators and memories, right? That's where it can help. However, it cannot help the latency inside flash memory. It cannot help, the cost of fab of flash memory, right? Or cost point. And it also cannot help the Ethernet latency, right? So given that in the mind, then we can see if the system is bottlenecked by the latency and the communication efficiency of the bus in the server, then it's going to play a huge a role for that, right? So especially, then we know for the in-memory computing, right, you need a lot of memory and the communication between the computing accelerator and the compute memory. And that's going to be the place that is going to really shine.
Okay, thanks. And Chris, did you have anything you wanted to add to that as an ultimate customer of this kind of hardware?
Sure. So I don't know. Let me take like the exciting topic of the past 5 years, right? Really, which is AI, right? So I think if we look at the trends there, AI is fundamentally extremely data hungry, right? And it's only getting more so. The interesting point, though, there is the access latency to that data so that you can do some inference on it, for example, is equally important to the amount of data that you have access to. So what that drives is a need for both a larger memory footprint and higher bandwidth at the same time to that larger memory footprint. One of the fundamental limitations we have with CPUs today is you can only pack so many memory channels into one package, right? You run out of pins, you run out of power, you run out of package space and so on, right? So one of the benefits that we get out of CXL is that we can pull some of that capability back out and we can further scale, right? So if a CPU has 8 channels today and I have a use case that could take advantage of double that many channels, I could potentially do that on CXL, right? I can expand that memory and that bandwidth across CXL as well. And there are absolutely use cases that are emerging that will take advantage of that.
Okay, thanks. And Glenn, I know you didn't want to answer this question, but it sounded like you wanted to make say something, some particular points you wanted to make. Do you want to talk about just briefly about a topic that you wanted to get across during our meeting?
Sure, yeah. I think a couple things. So it's super exciting that the CXL consortium has come together with such kind of groundswell of support from ecosystem partners. I've never seen it happen in my career where a consortium or effectively a de facto standards body just got galvanized so quickly. When you think about it, we have support for all 4 of the CPU ISAs, CPU processor architectures. AMD's here representing x86, x64. We also have ARM holdings. We also have PowerPC. So to kind of have that weight behind support for CXL is outstanding. Part of why I wanted to ensure that I gave my colleagues a chance to talk first was I feel that as a hyperscaler along with Facebook,
that's true.
Probably driving a lot of demand, and I want to make sure that kind of the requirements that we've asked the industry to deliver are something that I hear my colleagues say, just so I can kind of see how the message is getting through. I think I might amplify too what Chris said in terms of one of the primary drivers of CXL in general, but also what we're talking about here at the Persistent Memory and Computational Storage Summit is just the prevalence of AI and what AI means. Like the number of industry or partner feedback meetings that I've been in over probably the last 5 or 10 years, where the discussion turned into making a monolithic CPU complex, bigger, more cores, et cetera. And the discussion turned into how do we feed the beast? How do we put more IO, more memory? Now it is much more about kind of heterogeneous computing, doing computing closer to the data so that some of those AI models that Chris was speaking to can really take hold and we kind of eliminate those bottlenecks that we've experienced in the past. So the things that we're talking about here, Microsoft super excited about. We have a lot of projects in the works that we'll talk about at the right stage. But yeah, just the momentum behind CXL and CXL to capitalize on what we as an industry need is just kind of off the hook right now.
Well, let me ask a question that, we've talked a bit about the hardware. Let me just ask a question to you folks about the software and memory management. So how's that going to change with CXL? And let's see, this time, why don't we start with Chris?
So I actually think it presents us with an excellent opportunity. So I think to start with, we can treat CXL memory in the same way that we treat multi-socket memory, right? So we can think of CXL memory as memory attached to a socket 1 that you're accessing from CPU 0, for example, right? So in that sense, it's fairly transparent. Having said that, I do think there's a good opportunity here where we can start doing more intelligent things at the kernel level to decide where should we put certain pages, for example. Is it more optimal to keep them in the natively attached memory or in CXL attached memory, or perhaps in yet another memory device, right? So there's an opportunity here for us to create more tiering and to do a better job of optimizing where we put different pieces of data.
Depending on latency, I guess.
On latency, access characteristics, how, there's different ways you can analyze the traffic patterns, for example, and make decisions. But yes, exactly.
Okay. Leah, what do you have any comments on software memory management, how that's going to change with CXL?
Well, it's been a while since I've been in software, but from my understanding is I think that it's going to end up lowering the overhead of memory management, especially when you're talking about virtualized environments. The complexity of memory management gets pretty insane. So, and you have different levels of memory management. You've got it at the virtual level, you've got it at the physical level, and then you've got it down at the bare bones level. And so managing all of those and making sure that you're not missing out on performance from an end user point of view. I think that this is going to cut down on some of the overhead. We'll see how much. I'd like to see it by at least a magnitude. But I think that once we get into the complexities on how we can use this, especially in virtual environments, I think we're going to see a lot of efficiencies. But I think it's going to take a while before we actually realize all of that.
Okay, thanks, Leah. Hao, maybe you could give some input on that. Software and memory management, how's that going to change with CXL?
This actually reminds me when we transition from HDD to SSDs, right? So we see tremendous opportunity for the data storage management software, file system, right? There's a huge improvement from that. With the CXL, we're going to see much more capability for us to extend the memory as we are connecting to accelerators, right? That actually will show the similar opportunity as we see when the flash get into the market, the SD market. So I'm really looking forward to that.
Okay, great, thanks. Glenn, what do you have any comments on software and the memory management? How's that going to change? People talked about tying that into changes in storage. What do you think is going to happen there? How's that going to impact you guys?
Yeah, something we've looked at for the last couple of years are opportunities to kind of get existing software and existing controllers out of the way of what we want to have happen as a hyperscaler. It's been maybe not a mantra, but something we've talked about where we'd love access to the raw media, right? And maybe some basic functions performed locally, like garbage collection and a few others are okay. But otherwise, we feel that we know enough about our data flows and data patterns that we can do really intelligent things with access to the media. And I think that's something that CXL enables. So, as it takes off, we're excited to be there and excited to take advantage of it, thanks to CXL.
Well, thank you very much, Glenn. Stevie, how about you?
Yeah, I could probably spend an hour on this one.
I know you could, but you can't.
So I think the first thing is kind of tied to what Leah said and something I mentioned earlier. The fact that we have these larger power envelopes and the ability to develop quite sophisticated controllers means we can push some of this memory management down to the devices.
Yeah, okay.
A very simple example is in virtualized environments, SRIOV or its equivalent for CXL, and actually carve the device up at the hardware level and give parts of the device to the different virtual machines that want to run above it.
Interesting. So virtual, actually a portion, disaggregate the device itself, sort of.
Kind of carve it up.
Carve it up, rather. Yeah, it's probably better.
Allocate it
Yeah.
to different user space, but in this case, VMs, right?
Huh.
And there's very interesting things to do there. But I think another thing that gets very interesting is tied to what Chris said earlier, which is once we have some kind of almost NUMA, right? So non-uniform. Once we have that level of awareness around CXL devices, it may make sense to push certain computation tasks down to those devices, right? So I think memory expansion is a really important use case for CXL, but I think right on its heels, there is in-memory computation, right? So now that I have a whole bunch of like 2 terabytes of data on a CXL device, and I want to look through that data for a certain expression, or I want to do inference on it, do I need to pull it back to the processor and run ISA-based code on it? Or can I have an accelerator down there with all that memory? And can I pass a command in via some standardized framework to say, can you process this couple of terabytes and tell me what the answers are? And I think that's where things can get very, very interesting.
People have talked about that for decades, and I'd love to chat with you more about how we do that. But I think I'm going to ask David if he has any more comments on, how software and memory management is going to change with CXL. Oh, I think you're on mute.
Yeah, sorry.
There you go.
I think this reminds me of an old joke that the old there's a Volkswagen Beetle commercial, right? That they say 0 to 60, and the answer is yes, right? So the answer to this question is how is software and memory management going to change with CXL? And the answer is yes. So CXL is so CXL is a tool set, right? It enables you to do many interesting and exciting things. In the immediate future, like as what kind of Chris is pointing out, we're going to build devices and products that would enable sort of existing devices to run, existing application to run as well as it can. But as the ecosystem grows up, we'll start putting in the awareness of the topology, and these CXL will enable new system topologies. And as we get switches in there, we'll be able to enable memory disaggregation, memory pooling, right? Striping to different things. So that would introduce new levels of complexity, new levels of system architecture possibilities. And then you're going to need new sets of software and strategies to manage these new ecosystem, right? So again, it's the kind of the run, crawl, walk, run kind of, and then fly model kind of thing. And then so we'll do this step by step. And I'm not going to sit here and say that, yeah, this is going, I see 10 years out, this world's going to change in this way or that way. So I can say, yes, you're right, it's going to change, and there'll be a lot of things coming. But I think we're still at the kind of crawl stage. We're making things that make the existing applications run better. And then the next step, we'll bring the new and exciting things in.
Thanks, David.
In the years to come.
Thanks, David. Oh, we have actually two we have one real question, and one is you just actually got it started. We'll make that next question. But first, a question from the audience. And I want to say, be sure to notice that there's a Q&A thing on your screen that you can make questions. This one is from Stephen Heller. And I'm going to ask this one to Glenn, because he says, is Visual Studio going to allow us to write programs that target computational memory? Because he says that would be awesome. This is Stephen Heller. What do you think?
Yeah, We have no news to share today.
No announcements you want to make?
No announcements, but it's logical that as things like computational memory, computational storage, and any sort of computational hybrids that exist between them, as those take hold, certainly Visual Studio and our developer tools support, a tremendous number of environments. So it's, logical to project that things like that could happen. To reiterate, no news at this time.
Well, you have at least one fan out there who's waiting for it.
I love it. I love
Yeah.
it. Yeah.
So, and we have Mark Carlson, who reminded me, and actually, David, you brought it up first. Let's talk about memory pooling and shared memory. David, why don't we start with you on that one?
Okay. Yeah, so one of the exciting things about the CXL, especially CXL2, right, is that it brings in the infrastructure to enable a tier of switches in there. And that would enable a single host to access multiple memory devices, or the reverse, right, multiple hosts to kind of, quote unquote, not share, but access a pooled memory device or a pooled multi-logic device, right? So these are things that are possible, and I think we're studying both to see what makes sense and how we can deploy it. And as Chris alluded to earlier, and the benefit of CXL is that it now has the media controller on the device side, so that we can also put different types of media and accommodate a split transaction in, so that we can have variable support as well. So not only supports structured memory, but also different latency, different bandwidth characteristics of memory within the CXL sort of memory system, if you will. So I think, and again, this is CXL is a tool set, right? And how it will be used will depend on the evolution of the application. That will, again, depend on what Glenn and Chris's companies will see, how they see fit to deploy and use these applications and use the CXL appropriately. So I think I'll use that as a segue to kind of defer to them to expand on this point.
Okay, well, let's ask Chris then. We'll take him. What do you think about pooling and shared memory?
Yeah, so I think let's almost start with the first step in that evolution, right? And that first step in that evolution is actually to tier the memory. As soon as you pool it, you're essentially talking about quote unquote FAR memory by default anyway, right? And I think fundamentally, we will see tiered memory with CXL, right? And there are enough applications at this point. I was talking about AI earlier, but we already have to tier there, right? It's not possible to use a single device or even a set of devices to store and access all that data.
Because it's so big, right?
Exactly, and because there's such a range of access characteristics as well, right? So it doesn't make sense to store it in one layer. So I think fundamentally the answer is yes, absolutely, we'll do memory tiering. And a natural evolution of that is as you get to that point, you'll start thinking about aggregating some of those data sets in a pooled place where multiple devices can access it, right? And whether you partition it so that it's privately accessed or you consider sharing mechanisms is a further evolution of that, right? You have to decide what degree of optimization and complexity you want to take on.
Okay. Stevie, how about you? What do you think with regard to pooling and shared memory? I think you're on mute. Yeah, you are on mute. Uh-oh. Leah, why don't you take it up while Stevie tries to get his equipment to behave?
When I think about shared memory, a lot of people think, just in the server and data center space, but
I see it. Look.
Another thing to think about is, the space that I work in at AMD. We develop workstations and high-end desktops, and memory management also becomes an issue there as well, because a lot of industries are purchasing those products instead of servers because they are easy to manage, it's easy to use, and drilling at an oil field, those types of things. And so the dealing with very large data sets in a client system is something that does exist. It's not just gaming, it's not just M&E, but also finding in the scientific community that they're finding it very useful to deal with very large data sets. So therefore, being able to have the advantage of memory pooling and parallelism around memory pooling, I think we're going to see increased use cases and applications around that we haven't seen yet.
Okay, thanks, Leah. Hao, do you have any comments on pooling and memory sharing?
Sure. This is, I think, would be one of the most exciting features and opportunities with the CXL, right? As Chris mentioned, there are a lot of applications are already waiting for this to happen. What I see, I want to resonate a little bit about, everyone heard about disaggregation, right, at the storage. So before we can do disaggregation, we need to aggregate first. For example, the NVMe is the is the way to aggregate a lot high performance, high capacity SSDs together, so they can disaggregate it, and the many compute node can share that those data storage, right? So I think CXL is going to do similar things for the memory. It enables a node to a computer node to aggregate a lot memory together, right? Then which can be shared as a pooled memory or file memory to many other computer nodes for that, right? So that's why the CXL is going to be really helpful to make that happen.
Okay, thanks. Stevie, one last chance. See if you're it's not going to work.
That was very painful. That was my page faulting.
Go ahead, Steve.
So I think it really is a brave new world here, and it's going to be very exciting to see what people come up with, because I think we'll be able to mix and match devices and build different devices to do a lot of this in different ways. So for example, we can have devices that say they expose massive amounts of memory, but maybe a lot of that memory is actually backed by solid state drives, right? So when the host asks for data, maybe it's served from Optane if it's in the Optane, but maybe you have to go out to NVMe disks to get it, right? So how does an application handle that? How does an application become aware of that? Mark, in his question, talked about peer-to-peer. So another very interesting example is if I have multiple CXL devices with different types of memory on them, can I move the data around behind the processor's back using DMA and a peer-to-peer approach to kind of put the data where I think I want it to be? Right. And how on earth does the operating system
know you did that,
right? Because now you're moving data behind the OS's back, right? Which is kind of crazy, but very exciting. So I think there really is a brave new world coming, and I think there's going to be a lot of really interesting innovation and really interesting products that come out in this space.
Huh, wow, fascinating. I've got, maybe I'll start with Chris on this one, just because you may give the official story. So I know I've listened to some of the briefings the CXL group has done, and at least in one of them, there was talk about Gen Z, and Gen Z, the role it might play working with CXL. So maybe start off, can you tell us what role Gen Z will have in memory architectures that include CXL?
Sure. So between CXL and Gen Z, we have a memorandum of understanding. So we do have some partnership established there. The perspective at this point is that CXL and where we're taking it, at least in the near term, is really focused on within the server or very close to the server in terms of memory disaggregation, if we're going to use that term, or memory pooling, for example. And Gen Z has really been focused more on a fabric approach, right? So they're really focused on rack level or multi-rack scale disaggregation. And so I actually think at this point, they're quite complementary, right? And we're exploring ways that they can actually interact with each other in a complementary fashion.
Thanks. Would anyone else like to comment on Gen Z and CXL? Oh, go ahead, Glenn, go ahead.
Yeah, so along with Chris, I'm a member of the CXL consortium. I chair one of the work groups. In addition to the MOU that Chris describes, we also have a technical working group that's focused on interop between CXL and Gen Z. I think Chris nailed it. Yeah, at the end of the day, you can think of CXL within the node, Gen Z within the rack, right? But we want to make sure that our customer, and I think with those kind of sweet spots, it's not difficult to sort of find the right right interconnect or the right technology for the application. We want to make sure that customers that want to go across the boundaries just have the easiest time possible. So the interop that we're driving between the two protocols / interconnects are something that are just going to help us achieve mega scale beyond what we can do in the node, and with the kind of latencies that we can achieve in CXL.
Okay, great. Anybody else want to make comment on Gen Z? Okay. Otherwise, so I know that there's a few of you that definitely want to talk about this and have already talked about this, but why use CXL with accelerators, and what sort of accelerators will you be using? And maybe we'll start with Hao on this one. Go ahead.
For this one, I think I want to echo what Stevie mentioned, that with CXL, we can put a lot more power in a module, right? That the typical DIMM cannot do, right? So by doing that, that gives all the accelerator or some functions that need a lot of communication with memory, a great opportunity to do that, right? Especially in the in-memory database AI type of workload.
Okay. Stevie, you want to add, you're another advocate of accelerators. Go ahead.
I'm shameless plug. I'm a co-chair of the computational storage standardization work inside NVM Express, right? So we've already seen that, at least for larger kind of IO sizes, the kind of block or key value or zoned kind of levels of data, there really is a desire to be able to push compute from the host processors down to these types of devices, right? Whether they're PCIe attached or NVMe over Fabrics attached, or perhaps coming soon CXL attached. So I think there really is a desire to be able to, in a vendor neutral way, move bodies of work off a host processor to accelerators. And I think CXL just gives us a new flavor, a slightly more memory centric flavor for doing that. And so I'm hoping that a lot of the work we do in the NVMe working group and in SNIA's computational storage space will also translate over to computational memory, which I think will be more CXL based. But saying that, I do see that there's a potential overlap between CXL and NVMe and even SDXI, which was talked about earlier. And I think there is, there's going to be a need to make sure those three standards evolve cognizant of each other, so that we get the best out of all three of them.
Well, maybe that I should ask David that about well, there's the next one here, talk about accelerators and what kind of accelerators we use at CXL. Go ahead, David.
Well, I think I think unfortunately most of the good points have been stated already. But the small, I think the CXL enables the fine granularity data movement, so that makes the byte size, cache line size rather, data easier to move around, and makes the programming, the coherency makes the programming model easier to deal with for the software programmer. So those are the most sort of immediate and benefits that CXL provides. But I want to, if I may, go to a slightly different tangent that go to something that Steve pointed out a little earlier. The DIMM socket is, has been sort of designed and optimized to place DRAM devices for what, three decades or 4 decades now, and it's just not a very good place to put anything else. And so now CXL, moving it to the PCIe sort of side of the infrastructure, enables us to have a common sort of slot, if you will. Now you can put in different things. You can put in accelerator, you can put in storage, you can put in memory, right? So depending on how you want to use it, put in whatever it is that you want, for system ultimate system level flexibility have the range of power envelope available in that socket as well. So I think that's part of the excitement that we see people looking in and saying, well, I have a much larger canvas with which that we can sort of go and do different type of artwork, if you will, right? So I think CXL provides that canvas, and I think we're just looking around for the everyone's itching to of art on this case.
You actually bring up an interesting question. All this stuff's going on PCIe. Are we going to overload the PCIe?
You just add more.
Just add more.
We do.
Okay. Go ahead, Leah. It's your turn.
I mean, we don't have that problem.
Don't have that problem. Okay.
Yeah, we just add more. But the point that I think Stephen brought up earlier about being able to offload tasks from the host CPU into devices where things could accelerate, I think is something that we're going to see more of over time. For example, with the systems I work with, graphics is really important. And so we would love to be able to see texture and rendering, those activities where it goes back and forth between the host CPU and graphics. There's a lot of overhead that could be cut down if we just dealt with large data sets locally and be able to handle those types of tasks. So, if you're gaming and you see the hair flow, the amount of host CPU and memory that it takes just to see the hair flow is a lot. And so if that task can be pushed down to a device that can handle that for you and just give the results back to the host CPU to just generate out, I think we're going to see experiences change. I think we're going to see experiences change in, like I mentioned earlier, in the scientific community. We're in dealing with very large data sets, being able to offload a lot of computational information. You're going to see, for example, dealing with DNA in the medical industry. They're trying to figure out, if you've got a certain kind of cancer, they're trying to figure out what drugs will work the best. Well, wouldn't it be nice, instead of taking 3 weeks to do that, because it'll take just that long to match your DNA to the right drugs, what if the doctor could do it right there in his office, or do it within a couple of hours and send you an email, and you're on your way? So I think we're going to see a lot of industries open up in different ways when we're able to offload tasks intelligently.
Thank you. More processors, more processing in more places.
Yes.
Yeah.
And more PCIe.
Stevie, his talk, he talked about offload everything, right? So
yeah, there you
go. Glenn and Chris, did I cover this with you already? I can't remember that, the accelerators. I don't think we did. So,
yeah, so
Tom,
maybe allow me to emphasize a couple of things that the folks here are getting at.
Yeah.
I think that one of the key points here is data movement, right? And the side effects of the data movement. So fundamentally, there are two big pieces to this. The first one is the latency involved in that data movement. Many of these processing or operations that we're talking about here are highly latency sensitive, right? Yep. So that entire aggregation there is probably millions, if not in some cases trillions of operations, right? And that aggregate latency becomes an important factor, right? So by the time you add up all of these little operations, you need to minimize that latency, right? So keeping the data where it needs to be minimizes that latency, right? Instead of having to move it around or copy it around between different places. The second piece here is from a power consumption perspective. Every time we move data around, it's extremely power intensive. Every bus that we send it across is very power intensive, right? So the more data we send and the farther we send it, the more expensive that operation becomes from a power perspective. And yeah, increasingly in this world, we're becoming power constrained, right? We cannot build enough data center capacity, we cannot build enough power grid capacity, et cetera.
Yeah.
Right. So keeping data where it needs to be power efficient is huge. So I just wanted to emphasize those two pieces.
No.
And that's really where CXL will help us.
Really good points. Glenn, do you want to add to that?
Yeah, I think that was really well said. I think two things that tend to get glossed over. So for the hyperscalers, two of the biggest drivers of our business are AI and just public cloud, right? So hosting tenant VMs. With AI, you've got, models right now that are taking, we've exceeded millions of parameters. Now we're into billions and, looking on the horizon with trillions of parameters. Are you going to keep all the parameters for the models in sync, right? You're going to need something that's just where coherency is just built in, across just a gazillion number of GPUs. It's probably number one. I think the other thing that I think about too, in the public cloud hosting business, when a customer picks a VM, it's really tough to right size, or frankly, we can't right size the VM or the memory that's allocated to that VM. We have a general size of a VM, but we can't peer inside. We have no idea what our customers are doing when they pick that VM. So if you look at that in the aggregate, the ability to do something like memory pooling and memory expansion is fantastic, because then it sort of gives you like a memory bursting capability where you can say, this tenant needs more memory, let's give it to them. What happens right now is there tends to be, it's a little bit like overbooking a flight, right? Where you provision memory for, some, nominal case, but that doesn't meet the needs of each, right? And it tends to either over for some and then under for others. And we take steps to handle the overages for some, but it'd be better if we could kind of right size in real time. So those are probably two use cases that I think maybe not get glossed over, but don't get talked about enough with CXL.
Yeah, great. It's interesting. We find new ways of doing the things we've been doing, with new tools at a different level than we've done it before, it seems.
Yep.
So what are some good use cases for CXL-based products? And, you guys are the users, so maybe I'll start with Glenn. You just spoke, want to speak again.
Yeah, a use case that we haven't talked about, and I think Stevie talked about this a little bit when he talked about carving up the hardware, right?
Yeah.
Is if you carve up the hardware, and if it's something virtualized like an SRIOV implementation, data protection and security and integrity becomes tantamount, right? It's the noisy neighbor or nosy neighbor problem.
Nosy neighbor, yeah.
Where you sure as heck better be darn sure that what's happening in one part of the hardware, it has minimal opportunity for exposure to other parts of the hardware. And CXL does have some fantastic security capabilities built in. I think security is another use case. It's a little bit unsung, but at Microsoft, we're really excited about security because we do see that, the opportunities to carve up hardware more and more so that you get kind of that hyperscaler benefit. And we can, partition assets below so that we can, segregate and have almost like a bare metal or bare silicon experience, for the customers that need it.
Great, thanks. Chris, did you have anything on that to add to that on the applications?
I think we've covered
a bunch
several. Yes, exactly. I think maybe the only one I will add is we have some unique cases as a hyperscaler where we have common server building blocks that we have right-sized because this is our most efficient, most highly used building block, right? And the challenge though with that is that we often run into applications that need higher capacity memory footprints, right? So for example, in-memory caching solutions. The issue then becomes we cannot provide enough direct memory capacity for those solutions because our building block is so small, right? And so we need a more modular way to provide that extra capacity for these specific applications without pushing that burden into all of the servers, right? So I think CXL allows us to do that as well, because now I can add a CXL memory block to these specific servers as a modular piece, and then just enable those applications to run without becoming memory bound, basically.
Okay. Anybody else have comments that we haven't covered yet on applications, potential applications?
One thing I want to bring up is this whole thing reminds me of Sun Microsystems days. I don't know if folks remember the network is the computer.
Oh yeah, of course.
And yeah, and Sun did something. It was in the scientific community that was interesting, and I think CXL is actually going to be able to realize this at a much grander level.
Mm-hmm.
They were able to take a network of universities and be able to pool the CPU, the memory, the storage. So if you were working on something very computative and very intense, you could actually borrow CPUs and memory and storage from a neighboring university to be able to take care of your computational needs. And then when it was done, you give it back and somebody else uses it. And so there was this network where it just went around and looked for freed up devices and put them in a pool. Yep. And it was something that was very, very closely managed at the time because we didn't have the technology to do it yet. But I think CXL is actually going to expand that use case. I think we're actually going to see the reality of what Scott McNeely was talking about.
Mark Carlson just commented that you're talking about a Sun Microsystem project called N1.
Yes. He remembers the name of it. He remembers
it. All right. Thank you, Leah. Well, it's really interesting. We do sort of, keep reinventing things, but at different levels than, that we've done before. We're breaking things down to smaller and smaller level. I'm still waiting for that atomic storage device or maybe subatomic storage device come out here.
But
we're getting, you won't be able to see it. That's right. And the bits may or may not be there, but
that's right.
Let me ask an important question here is, when will CXL solutions be available in products? When are you actually going to be able to see this in the wild? Does anyone want to start with that one? How about someone who makes stuff like David? You want to talk about that?
No, I'm not here to. I can't make product announcements here.
Yeah.
But I think starting and toward the end of this year, beginning of next year, we should see some things on the market, and it'll be the kind of the proverbial hockey stick curve kind of thing, right? So we'll see some very initial stuff, in a year or so, and it start to kind of pick up momentum in next year, 2022, and I think we'll see a kind of a high volume of stuff in 2023. I think just my personal guess.
Okay. Anybody else want to talk about that? When we might, will we see products next year? It sounds like we're going to start seeing some stuff.
Yeah, I can't speak on behalf of Microsoft, but I can for the consortium. I'll just say that we have a ton of products in the works, an absolute incredible number. Yeah. And we've spun up all the programs where we ensure that there's awareness of them. You'll be able to go to the CXL Consortium's website and see which devices are compliant with CXL and what version of CXL. It's pretty exciting. I can't name individuals, but we're seeing a great kind of allocation or spanning of the different use cases that we have and the different CXL device types, consumption of CXL.io, .mem, and .cache. So yeah, it's a tough answer, but you have to stay tuned to when it hits. It'll be like a tidal wave. CXL will be to the data center like PCIe has been to devices.
Sounds exciting. I also want to we're getting close to the end here. I want to recognize that Stevie answered one of the questions that came there, so we don't need to ask that one. And the last thing is, how can I get involved in CXL and the activities that you guys are doing? Is that Chris, or you want to talk that?
Yeah, either I or Glenn can probably tackle that one.
Yeah.
Yeah, so I think, as I mentioned earlier, certainly the best way to get involved is to join the consortium. We have different levels, including an adopter level, which is free. Right, so you can sign the agreement and join and get access to the specs directly. Certainly, we'd love to have you as a contributor, right, which will help us develop the next generation specs. Otherwise, as I mentioned earlier, follow us on Twitter and LinkedIn, and look for some more exciting announcements.
Well, thank you, folks, very much. I really appreciate the chance to be able to moderate the session here. I think you guys are just a great session. I think we talked about a lot of interesting insights, and I hope that the people listening are going to want to get involved in CXL, use it, maybe participate, at least sign up for the free membership, if nothing else. Thank you all very much.
Thank you.
Thank you.
Thank you.
Thank you very
Thank
much.
you, everybody,
Thank
for
you.
listening. Bye.
Bye-bye.